Hi, this is Somajit from Educators Online Education System. In today's session, I'll discuss on the topic polynomial of single variable. In this topic, I'll be focusing on the definition of polynomial, degree of the polynomial, different types of polynomial, zeros or roots of the polynomial. This is very important. Zeros or roots of the polynomial. Relation between roots and coefficient of quadratic polynomial. This is also an important topic. Now let us see the definition of the polynomial. Polynomial is an algebraic expression which never includes fractional or negative exponents of the variable. That means we need to look at each power of the variable, either those number, each power of the variable are whole number or not. If that is not a whole number, then that is not a polynomial. Like, see, each power of the variable is here 7 is a whole number, again 5 is a whole number, 4 is a whole number, 3 is a whole number. So this particular algebraic expression is polynomial. Again, if you just consider next example, 5x power 5, the power of the variable is whole number. Again 7x cube, the power of the variable is a whole number. Again, power of the variable is whole number. So 25. 25 can be written as 25 into x power 0. 0 is a whole number. So this particular algebraic expression is a polynomial. Now if you look at next example like 25x cube, the power of the variable is a whole number. So that means this is also a polynomial. Now then, what kind of algebraic expression is not a polynomial? Now look at, polynomial cannot contain the following: division by variable, negative exponents, fractional exponents, or radicals. Like let us take some example like 5 p of x equal to x power 5 plus 2x power minus 3 plus 7. Power of this variable is a whole number, but what about this power of this variable? 2x power minus 3. Minus 3 is not a whole number. So that means this is not a polynomial. Now again, if you take this, this example like x power 10 minus cube square root of x cube plus 20. That means this can be written as x power 10 minus x power 3 by 2 plus 20. This particular power is not a whole number. That means this particular algebraic expression is not a polynomial. Now if you take this example, power of this variable is a whole number, power of this variable is also whole number, but what about this power? This power of the variable is not a whole number. So this particular algebraic expression is not a polynomial. Now if you take next example also same, like power of this variable is not a whole number. So this is not a polynomial. Even if you take some other example like p of x equal to x cube plus 3 by x power 5. See, division by variable is not allowed. So this means this is not a polynomial. Now let us see the degree of the polynomial. What is degree of the polynomial? The highest power of x in a polynomial p of x is called a polynomial. Then what is highest power of x? Let us see. Highest power of this particular algebraic expression. Here is 3, here is 1, here is 2. So highest power is 3. So that means this particular polynomial is of degree 3. Now if you take example like say, let us take some random example like x cube plus 3x power 7 minus x power 10 plus x power 20. This is no doubt this is a polynomial because each power of the variable is a whole number. Now look at the highest power. Highest power is obviously 20. So this polynomial is of degree 20. Is it clear? I think obviously it is clear because what we need to see the highest power of the variable. That is nothing but a degree of the polynomial. Now, what is monomial? Now, let us see different types of polynomial and the examples like monomials. What is monomial? Mono means one. That means a polynomial containing only one term. Only one term. That is nothing but that kind of polynomial is known as monomial. Here see p of x equal to 6. P of x equal to 6 is a polynomial because 6 can be also written as 6 into x power 0. 0 is a whole number, so this is a polynomial. So it is containing only one element, sorry, one term. That is why this particular polynomial is known as monomials. Again, p of x equal to x squared. Again, it contains only one element. It is only one term. So that means this is nothing but a monomial. Now, if we take example like p of x equal to 7x squared, that means this containing only one term. That is why this is a polynomial. This polynomial is known as monomials. This type of particular polynomial which contain only one term is known as monomials. Now let us see what is binomial. Bi means two. That means a polynomial with only two terms, such as like if you take 6 plus x, 6 is one term, x is one term. So that means this polynomial containing two term total. So that is why this particular polynomial is known as binomial. Now if you see x squared plus 3x, x squared is one term, 3x is another term. So that means p of x containing two terms. That is why this kind of polynomial is known as binomial. Now if you take some other example like say p of x equal to x cube minus 3x. This is containing two terms. So that's it. That is why this is a polynomial. This polynomial is known as binomial. If p of x equal to say x square plus 3x plus 1, is this a binomial? No, because see here this is one term, this is one term, and this is one term. That means total terms in this particular polynomial is 3. So this is not a binomial. Instead, a polynomial containing three elements, we can say those kind of polynomial is trinomials. Now see, now next type of next, let us see what is constant polynomial. Constant polynomial are those polynomial whose degree is 0, or a polynomial contains only number terms. Like p of x equal to you say like 6. 6 is a number term. There is no variable term. So what is the degree of this particular polynomial? Is 0. So this kind of polynomial is known as constant polynomial. Say like minus 3, 0, 2, root 2, root 3. Like p of x equal to, if it is root 2, square root 2. This is also polynomial. What is this type of polynomial known as? Like this is nothing but a constant polynomial. Because root 2 can be written as root 2 into x power 0. The degree of this particular polynomial is 0. So this is known as constant polynomial. Now let us see what is linear polynomial. This is very important type of polynomial, linear polynomial. Linear polynomial are those polynomial whose degree is 1. This is very important. Whose degree is 1. If any polynomial, any type of polynomial whose degree is 1, that is known as linear polynomial. The standard form of this kind of polynomial is ax plus b, where a and b are constants. Like for an example, like say p of x equal to 3x plus 2. This example is of this type. Ax plus b in this form can be expressed as ax plus b, where a is 3 and b equal to 2. If you consider with this general form of this polynomial, like a equal to 3, b equal to 2, and degree of this particular polynomial is 1. That is why this type of polynomial is known as linear polynomial. Now let us take some other example like p of x equal to x. Obviously, this is of degree 1. That is why this polynomial is of linear polynomial. Take some other example like p of x equal to x minus 3. Again, this is a linear polynomial because degree of this polynomial is 1. So this is also a linear polynomial. Now then, what is quadratic polynomial? Quadratic polynomial, that means a polynomial whose degree is 2 is known as quadratic polynomial. Standard type, standard form of this type of polynomial is ax squared plus bx plus c, where a, b and c are constants. P of x equal to, like say for an example like x squared. What is the degree of this polynomial is 2. That is why this is a quadratic polynomial. Now if you take some other example like say p of x equal to 3x squared plus 6x plus 5. Again, the degree of this polynomial is 2 because highest power of the variable is 2. Therefore, this particular polynomial is a quadratic polynomial. Like for an example, take p of x equal to x squared plus x minus 3. So degree of this particular polynomial is 2. That is why this is a quadratic polynomial. Now cubic polynomial. Same as like before, like linear polynomial and quadratic polynomial. What do you need to look at? Look at the degree of the polynomial. If the degree of the polynomial is 3, then that kind of polynomial is known as cubic polynomial. For an example, like p of x equal to, if you take x cubed plus x squared minus x plus 3. What is the degree of this polynomial is 3. So this is cubic polynomial. If it is a single term like p of x equal to x cube, this is also cubic polynomial because all other constant terms are 0. All other constants are 0. So what you need to basically we need to look at the degree of the polynomial. If degree of the polynomial is 3, then obviously that is nothing but a cubic polynomial. Now it's very important monic polynomial. Monic polynomial, it says like monic polynomial are those type of polynomial whose leading coefficient equal to 1. What is leading coefficient? Leading coefficient is nothing but the coefficient of the leading term. That means what is leading term? Let us see. Here what is the leading term? The highest power of the variable is the leading term of the polynomial. If the leading coefficient of the polynomial is 1, then that type of polynomial is a monic polynomial. Take some other example. P of x equal to say x power 5 plus x cube minus 3x squared plus 1. What is the leading term? Leading term is 5. X power 5. What is the coefficient of x power 5? Is 1. That is why this is monic polynomial. Now if you take p of x equal to like say 5x power 5 plus x power 3. Is it a monic polynomial? No, because the leading variable is x power 5. What is the coefficient of x power 5 is 5. X power 5 is 5. So leading coefficient is not equal to 1. That is why this is not a monic polynomial. This is not a monic polynomial. Now next thing is zero polynomial. What is zero polynomial? It's very simple. Keep it in this way. The polynomial whose coefficient are all equal to 0. Very important. Coefficient needs to be 0. Coefficients. That means the variables, like if you just take an example like 5 p of x equal to 0, that means this can be written as 0 into x cube plus 0 into x square plus 0 into x plus 0. That means each coefficient are 0. That is why this kind of polynomial are known as zero polynomial. For example, like p of x equal to 0x cubed plus 0. So each coefficient of the variable is 0. That is why this is nothing but a zero polynomial. Means first and foremost important thing, we need to look at the coefficient of 0. If coefficient of polynomial, all coefficients of polynomial equal to 0, then that is nothing but a zero polynomial. What is zeros? What is zeros of polynomial? This is different than zero polynomial. Zero polynomial means each coefficient should be equal to 0. But zeros polynomial is bit different. A very lot. There are huge different. Like, let us see what exactly zeros of the polynomial. Zeros of the polynomial px are all the value of x values that make the polynomial equal to 0. Means we need to find the particular value of x for which the whole value of the polynomial becomes 0. Let's see this example. P of x equal to x square minus 3x plus 2. Let us solve and find the zeros of the polynomial for this particular example. Like it's given P of x equal to x square minus 3x plus 2. Zeros, to find the zeros of the polynomial, first steps, what you need to do? We need to put p of x equal to 0 and find the value of x for which this polynomial satisfies. P of x equal to 0. That means we can do x square minus 3x plus 2 equal to 0. Now do a factor, middle term factor. X square minus, if you do it, this minus 3x can be written as minus 2x minus x plus 2 equal to 0. That means x minus 2 into x minus 1 will be the factor. That means x equal to 2 or x equal to 1. That means for x equal to 2 and x equal to 1, the polynomial will become 0. Let us verify. P of 2, that means for we need to put the value of x equal to 2 in this example. Let's see. 2 square minus 3 into 2 plus 2. That means 4 minus 6 plus 2. That means 6 minus 6 equal to 0. That means P of 2 equal to 0. Again, P of 1. P of 1 means 1 minus 3 plus 2. Put in this example. P of x equal to 1. Put in this x equal to 1. We get P of 1 equal to 0. That means what are the zeros of this polynomial? Zeros of polynomial P of x equal to x square minus 3x plus 2 are 2 and 1. That means zeros of this particular polynomial is 2 and 1. Now let us see this example. P of x equal to x square minus 2x minus 8. What you need to do first step? First step is P of x equal to 0. That means x square minus 2x minus 8 equal to 0. Do a factorize like previous. Like x square minus 4x plus 2x minus 8 equal to 0. That means factor we can get x minus 4 and x plus 2 equal to 0. That means x equal to 4 or x equal to minus 2. That means the zeros of this particular polynomial are 4 and minus 2. That means P of 4 obviously will get 0. Let us see. Let us verify. P of 4. That means we are putting the value of x equal to 4. That means it is 4 square minus 2 into 4 minus 8. That means 16 minus 8 minus 8, which is 0. That means P of 4 equal to 0. That means zeros of this polynomial 4 and minus 2. You can do the verification by yourself. P of minus 2 equal to 0 or not. Just verify by yourself. So zeros of the polynomial are, we need to find the value of x for which the polynomial becomes 0. Let us solve some other examples of this polynomial, like this kind of examples we need to solve. It's given like f of x equal to x squared plus 2x plus 2. We need to find the value of f. So let us write f of x equal to x squared plus 2x plus 2. We need to find the value of f. Now put x equal to 2 in the above expression. X equal to 2. That means what we get? F of 2. Wherever you see x, you put 2. As simple as it is. Like 2 square plus 2 into 2 plus 2. That means 4 plus 4 plus 2, which is nothing but 10. Then f of 2, what is the value of f of 2? Equal to 10. What I did? I did x equal to 2 wherever I saw the variable x. I put x equal to 2 and I found the value f of 2. Same as the previous example. Like let us write this question first. 1 minus x by 1 plus x. Now what we need to find? F of 1 by x. Now see, here it was x, here 1 by x. So the variable changed from x to 1 by x. Same like previous, put x equal to 1 by x in the above expression. What do you get? F of 1 by x. Now wherever you see x, you put 1 by x. 1 minus 1 by x by 1 plus 1 by x. Take LCM of the numerator. What? This will become x minus 1. Take LCM of the denominator. This will become x plus 2. This x get cancelled, so it becomes x minus 1 by x plus 1. So what is the value of f of 1 by x? What is the value of f of 1 by x? It becomes x minus 1 by x plus 1. Now see this example, like f of 1. Let us write f of 1 by y equal to its 2 by y minus 1 by y square. We need to find f of y. Now what it happened? Just look at. Here 1 by y, the variable is 1 by y, here the variable is y. So what we did? Like same way, the previous example. First rewrite this equation in the terms of f of 1 by y and then substitute. 2 into, we can write 2 into 1 by y minus 1 by y whole square. We can write. Now change the variable 1 by 2 y to y. Like put 1 by y equal to y in the above expression. What do you get? F of y. I have put 1 by y. That means wherever I see 1 by y, I'll put y. That is the main fundamental. 2 into y minus y square. That means is 2y minus y square. Then what is f of y? F of y is nothing but 2y minus y square. So it's very simple. Keep it very simple, like see the variable here 1 by y and we need to transfer this 1 by y to y and then you will get the value what is asked for. This is a bit tricky but it's also very easy. Like see f of t is given a minus t power n whole power 1 by n. Here the variable is t. Now what we need to find? f of t. Now see the variable of t. Here the variable is f of t. Now put t equal to f of t. That means wherever we see the term t, will put f of t in this above expression. That means we get f of t. I have put the value of t as f of t. So I get here the term t is there. So I will put f of t. Very simple. Wherever I saw the t term t, I have put f of t. That means it is a minus. Now I will put the value of f of t from the above expression. What is the value of f of t? It is a minus t power n whole power 1 by n power n. Now see, we'll solve this. A minus t power n 1 by n into n whole power 1 by n, because we know a power m whole power n is nothing but a power mn. That means the multiplication of this 1 by n into n get multiplied together. That means it get cancelled. So it is a minus, it remains like a minus t power n whole power 1 by n. Now simplify a minus a plus t power n whole power 1 by n. A get cancelled. It becomes t power n whole power 1 by n. This n get cancelled. It remains t only. That means f of t equal to t. What I have done, I have to find the value of f of t. f of t. That means wherever the term t is there, I have put f of t, and I have simplified. I got t. Very normal simplification. In this polynomial, what is given, note that, and what you have to find, note that. What you have to find, just put that particular variable in terms of the given polynomial, you will get the result. Now, which is very important, I have just mentioned earlier, the relation between zeros and coefficient of quadratic polynomials. Quadratic polynomial I have mentioned earlier, the standard form ax square plus bx plus c. Now let's say alpha and beta are zeros of this quadratic polynomial. What is zeros? That you know. Zeros are nothing but, I have just mentioned earlier, that zeros are nothing but that particular value of x for which the polynomial becomes zero. That means if alpha and beta are zeros of this polynomial, then what do we get? What is the relation between the roots and coefficient? I have mentioned the sum of roots, that is alpha plus beta equal to minus b by a, That is nothing but coefficient of x by coefficient of x square. What is coefficient of x? Is b. Coefficient of x square is a. That is why it is minus b by a. What is alpha beta? Alpha beta is nothing but constant term. What is constant term in this polynomial is c, and coefficient of x square. Coefficient of x square is a. That is why it is c by a. So we get alpha plus beta equal to minus b by a, and alpha beta equal to c by a. This is the relation between roots and coefficients of a quadratic polynomial. Now, what is remarked? Let's see. If alpha and beta are zeros of quadratic polynomial f of x, then polynomial f of x can be written as k into x minus alpha into k in x minus beta. Let us see some examples on this particular notes. If alpha and beta are zeros of quadratic polynomial, f of x equal to 6x squared plus x minus 2, then find the value of alpha by beta plus beta by alpha. Now consider this polynomial and compare it with the standard form of the polynomial ax squared plus bx plus c. What is the value of a? A is 6. What is the value of b? The coefficient of x is 1, so value of b is 1. What is c? C is minus 2. Then we know if alpha and beta are the zeros of the quadratic polynomial, that means alpha plus beta equal to minus b by a. We have just seen earlier, that is coefficient of x minus of coefficient of x divided by coefficient of x square. That means minus 1 by 6. What is alpha beta? Alpha beta is c by a. What is c here? C is minus 2, a is 6. That is nothing but minus 2 by 6 is nothing but minus 1 by 3. We have found alpha plus beta and alpha beta. Now we have to find alpha by beta. The value of this we have to find. Let's see. Alpha by beta plus beta by alpha. We take LCM, alpha beta. This numerator becomes alpha square plus beta square. What is alpha square plus beta square? I can use the formula, algebraic identities formula. That is alpha plus beta whole square minus 2 alpha beta by alpha beta. This is nothing but, let's put direct the value. Let's see what is the value of alpha plus beta. Alpha plus beta is 1 by 6. That means minus 1 by 6 whole square minus 2 into alpha beta. That is nothing but minus 1 by 3 divided by alpha beta. What is alpha beta? That is nothing but minus 1 by 3. Let's see. 1 by 36 minus and minus gets plus. That is nothing but 2 by 3 divided by minus 1 by 3, which is nothing but LCM will become, let's see, the numerator LCM is 36. That means 1 plus 3, 12 plus 36, 12 into 2 is 24 by minus 1 by 3. 3 12 is 36. That means minus 25 by 12. 1 plus 24 is 25. The denominator is 12, and so the result is minus 25 by 12. So alpha by beta plus beta by alpha is nothing but minus 25 by 12. This is like what exactly the zero means and how they are related to their the coefficient of the polynomial. If alpha and beta are the zeros of the polynomial, then alpha plus beta is nothing but minus b by a that I know the value of b and a. So alpha plus beta I have found the alpha plus beta. Similarly, alpha beta we can find and then substitute the value of alpha plus beta and alpha beta. So final result we got alpha by beta plus beta by alpha equal to minus 25 by 12. See, next example, like what it says. If the sum of zeros of a quadratic polynomial is equal to their product, like that means if all, like let's see what is the polynomial given. F of y equal to ky square plus 2y plus 3k. Given the sum of zeros of a quadratic polynomial is equal to their product. Let's say let's say alpha and beta are two zeros of this particular quadratic polynomial. From the given statement, what we get, sum of the zeros alpha beta is equal to alpha beta. That is given. Now let us compare with this with the standard form of the quadratic polynomial, that is f of y is nothing but ay square plus by plus c. If you compare with this, the coefficient of given polynomial is k. If you compare with this polynomial, we get a equal to k. B equal to we get 2. C equal to we get 3. That means what is alpha plus beta? What is alpha plus beta? We know minus b by a. That means minus b by a. What is value of b? Value of b is 2. What is the value of a is k. What is alpha beta? Alpha beta is c by a. What is c? 3. The value of a is k. Now we've got the value of alpha plus beta and alpha beta. Now by the given statement, it says the sum of zeros of a quadratic polynomial is equal to their product. That means we got sum of zeros is minus 2 by k, which is equal to 3 by k, because 3 by k is their product. Sorry, the mistake was like c was 3k. C was 3k. So if kk get cancelled, c is alpha beta is 3. That means this minus 2 by k equal to 3. That means k equal to minus 2 by 3. So what is the value of k? K is nothing but minus 2 by 3. Now given like p, now let's see the next example. Like it's given like p and q are zeros of the quadratic polynomial. Then find the polynomial whose roots are p plus 2 and q plus 2. This is very interesting question. To develop this problem, let us see how a quadratic polynomial can be defined using the zeros. We have previously seen if the quadratic polynomial ax squared plus bx plus c. This is nothing but the standard form of the quadratic polynomial. We have seen if alpha and beta are zeros of the quadratic polynomial, then we have seen alpha plus beta equal to minus b by a and alpha beta equal to c by a. Right? That means just see, look at this f of x. If you just take common a, that means it become x squared plus b by a plus c by a. That is nothing but a into x squared. B by a can be written as, it can be written as minus of alpha plus beta. C by a can be written as alpha beta. So this is the way we can write, or you can rewrite the polynomial using zeros. Right? What is a? A is constant. A is constant. Now let's see. Given polynomial Given polynomial f of x equal to given x square minus 2x plus 3. What is the zeros? Zeros given p and q. So what is p plus q? P plus q, the coefficient of x, that is minus of coefficient of x. Coefficient of x is minus 2 r, and coefficient of x square is 1. So this become 2. Pq, that is nothing but constant term divided by coefficient of x, that is 1. So p plus q and pq becomes, we got the value p plus q and pq. Now given whose roots are, if roots are p plus q and q plus 2, then what is the sum? Like p plus 2 plus q plus 2. We need to find the sum of the roots first. Like that is nothing but p plus q plus 4. That is nothing but, what is p plus q? We know p plus q is 2. That means 2 plus 4 equal to 6. We got the sum of the roots. Now, product of the roots, p plus 2 into q plus 2. This is nothing but, simplify, pq plus 2p plus 2q plus 4. If you just take pq plus 2 common, that means p plus q plus 4. What is pq? Pq is 3. What is p plus q? Is 2. That means 3 plus 4 plus 4. We get 11. So we got sum of the roots and product of the roots. So we can easily generate the polynomial. What is the way to generate the polynomial? Using the zeros. We have seen, like say this polynomial is denoted as c of x. We have seen some constant, say k, into x square minus of sum of the roots, minus sum of the roots is 6. So this is 6x plus product of the roots, that is alpha. That's all. This is the way. This is the required answer. I have developed the formula for you to generate the equation using the zeros. This is the main formula. If the zeros are given, then you can easily find, using this formula you can easily find the required polynomial or required equation. Now let's see the next example. Given minus 2 and 3 are the zeros of the polynomial, then what is the degree of the polynomial? Before discussing this, let's see If a polynomial p of x is given like x squared plus 2x plus 3, say it is minus 3. What is the degree of the polynomial is 2. That means we can find the zeros of this particular polynomial. Number of zeros of the particular polynomial will be 2. So if the n degree polynomial is there, then we can find the maximum zero is n, not more than that. That means if there are two zeros, then degree will be 2. If there are three zeros, then we can say the degree will be 3. That means we also seen using the zeros, we have seen the defining polynomial p of x like minus 2 and 3. We can write minus 2 and 3 if they are zeros. That we have seen like f of x is a polynomial, quadratic polynomial. If it is of degree zeros are alpha and beta, then f of x can be written as k into x minus alpha into x minus beta. Here zeros are given minus 2 and 3, so this can be written as k into x minus of minus 2 into x minus 3. That means k into x plus 2 into x minus 3. That means k into x squared minus 3x plus 2x minus 6. That means k into x squared minus x minus 6. Here again I have proved the zeros are 2 minus 2 and minus 3. So what is the degree? Degree is the highest power of the variable 2. So degree of this particular polynomial is 2. That's all for the today's session. In the next session, I'll be discussing on factor theorem, roots of the polynomial and their examples, and also different types of examples related to the polynomial. You can also visit us for taking online test on www.educators.com. Thank you.